Yes, students, now the next topic is the dependence of the rate of the reaction on concentration term, right? And this we can study under the rate law expression, right? Now we know that as the reaction will proceed, the concentration of the reactant is going to decrease, and the concentration of the product will decrease with increasing time. So we will plot the graph, right? On the x-axis we will have the time, on the time, and the y-axis we will have the concentration, right? And we will just see the variation of the concentration of the reactant and product with increasing time, right? So you will observe that let we have expressed the time in unit is minute, and here it is mole per liter, right? Now as the time will proceed, there will be decrease in the concentration of the reactant, right? What you see that in the beginning, right, we have got only the reactant, right? So in the beginning the rate of the reaction, right, that is decrease in the concentration is going to be sharp, and then it gradually slows down, right? That means the rate of the reaction will be faster in the beginning, and it will depend on the reactant concentration because we have good amount of reactant, and as the time proceeds the concentration of the reactant is decreasing. So what will happen, the rate of the reaction also slows down. This is for the reactant, right? So you can see that there is a decrease in the concentration of reactant. Now in case of product, right, as the reactant is decreasing in concentration, there is an increase in the concentration of the product. You can see in the beginning again it is sharp because more of the reactant will be changing into product. Okay, now as the time proceeds, the increase in the concentration of the product also slows down. Now the quantitative relation between the concentration and the rate of the reaction is given by the law of mass of action, right? So the law of mass action states that, or we can say it is a quantitative relation between the rate of the reaction and the concentration term, right? So it states that the rate of reaction at a given temperature is directly proportional to the product of molar concentration of reactant, right, raised to the power of stoichiometric coefficient. That means, right, so what we say that rate of a reaction at a given temperature, that the temperature will be specified, is directly proportional to the product of the molar concentration of the reactant. Or if you directly write down, is directly proportional to the molar concentration of reactant. That is also okay. And if you just complete it in this way, product of the molar concentration of reactant raised to the power of the stoichiometric coefficient, right? So if we take this, that we have got A plus B gives C, right? So here small a and small b are there. That time R is directly proportional to the molar concentration of A raised to the power of small a, and this is there, right? Now this stoichiometric coefficient is coming from the balanced chemical equation. Now if we remove this proportionality sign, we get R equals to small k in this way. Now student, here this small k is known as the rate constant, because it is a constant, it is a rate constant, or it will be known as velocity constant. Right, so here the K specify the rate constant. Now the rate constant plays a very important role, right, to decide or to predict the rate of a chemical reaction. Right, so here you can see that its relation is with the rate of the reaction. Students, so we will now discuss that how we are going to define the K, right? That what is going to be the K, rate constant, how we define the rate constant. So when rate constant, we can say here it will be, now if you have to define a K, so if the molar concentration of A and B is equal to unity, right, that is it is 1 mole per liter, right? So in that case, 1 mole per liter. So if we just put the value here, so what we will get? This is there. So if it's 1 raised to power any time, so it will be 1 only. Here it is 1 raised to power B any time. B can be and have any value. So we will get R equals to K. Right, so you can see that the rate of the rate constant is getting equal to the rate of the reaction when the molar concentration is unity, right? So how will we define now the rate constant? So rate constant defined as rate of the reaction, right? It is the rate of the reaction when molar concentration of reactant is unity, right? So when the molar concentration of the reactant will be 1, right, that time the rate of the reaction will be equal to the rate constant. Right, student? Now we have got certain characteristics of rate constant, that how it is used, right? So rate constant, it is a measure of the rate of the reaction, first of all, right? When we say it is a measure of the rate of the reaction, what does it mean? It means that if the K value is higher, right, greater the K value, the higher or faster will be the speed of the reaction or the rate of the reaction, right? So if we have got two reactions and if we are asked to compare the rate of the reaction, so we will check its rate constant or we will calculate its rate constant, and the one which will have the greater value will be the having the more speed of the reaction or higher speed of the reaction, right? So K is the characteristics of the rate of the reaction. Now second is that K is independent, that is rate constant is independent of the initial concentration of the reactant, right? It is independent of the reactant concentration, that what we have taken, right? So it only, okay, it depends upon the, we can say it depends upon the temperature factor. Now, so first point was that it gives us the extent of the rate of the reaction, right? Or we can say it's a characteristic of rate of a reaction. Second, it is independent of the initial concentration of the reactant, right? Third, every reaction has got a particular value of K, right? Every reaction has got a particular value of K. If the reaction will change, the K value is also going to change. Next point is that for a given reaction, if there is a change in the temperature, right, for a particular reaction, if there is a change in the temperature, the rate constant value is also going to change, right? That means it depends upon the temperature. So if the temperature will change for a particular reaction, the K value is also going to change for the same reaction, right? We can take that if we have got decomposition of nitrogen pentoxide, if it is carried at 150 degrees Celsius, it will have a K1 value, and if it is just temperature is changing from 150 to 155 degrees Celsius, then the K value will also change. It will change from K1 to K2, right students? And the rate constant unit, right? We can say that as we have got a definite rate constant unit of the rate of the reaction, but the rate constant unit will change in the order of the reaction. So we will discuss now later that what is going to be the order of the reaction. So just you will pen down that what are the characteristics of the rate of the reaction, right? So first one, again I am repeating, it is a characteristic of the rate of the it is a characteristic of the rate of the reaction, right? Second, it but every reaction has got a definite value of a K. Third, with a change in temperature for the given reaction, the K value will also change with change in temperature, right? And K value is independent of the initial concentration of the reactant, right? And the unit of the rate constant will change with the change in the order of the reaction, right students? So please get the things noted down in your notebook.